later. I don't know why these things happen. But let's try and avoid extra things like this. So yeah, we will present slides for you.
Right. Thanks very much.
This all correctly. We now have slides. Okay, can people out there hear me?
Hello, David. And I'm assuming we'll still need a note taker.
Yes, please.
Oh, no.
All right. Well, I can at least get the first two slides. This is the note well. You should be familiar with it. It applies to you as a participant in this meeting. And now we're on to Gory's item. We need a note taker, please. Let me see if I can get the relevant portion of the agenda pasted into the notes tool. All right, there we go.
Okay, we do need a note taker. It's going to be difficult to go ahead.
It's supposed to be 7.2. Okay. So we just need somebody to volunteer to please try to capture the important things that happen. We don't need the blow by blow, but we do need to record important points and important decisions being made. I will try to do notes. I hope other people are willing to help out.
I'll be doing that anyways myself, too.
If you just do it in the editing tool, that'll be excellent. Thanks,
Yep.
Wes. We'll try to do it that way.
So this is Michael speaking. I will also help.
Thank you. All right, and let's just simply do this collectively. Note takers, also please try to pay attention to the chat just in case something comes up in chat that needs to be said at the mic, or we need to get a break at the mic so the person on chat can speak. Okay. So this is this morning's agenda. Today is entirely L4S. I got one more slide coming, as you can sort of see in my side in my little bar on the side. That'll be an agenda recap. Then we need to look at the operational guidance draft, for which regroup adoption has been requested, and there's a call in progress. deal with the main LFRS ECN drafts, and then Ingemar has some slides on the relationship of on something about L4S and 5G. And let me take back the relationship word and let Ingemar speak to exactly what he intends to tell us. This is the agenda. Anybody want to bash it? Hearing nothing.
Yep. Can I?
Go ahead.
I thought we'd made it clear that Kuhn is doing 7.2, and I'm just wrapping up. So I just sent a note saying I don't think you've got Kuhn's slides in the meeting materials, but he has sent them because he CC'd me.
That's 7.3, right? The ECN drafts? Okay, agenda bash. Kuhn is presenter for item 7.3,
Well, no,
which
it's Kuhn and me. Kuhn and me. There should be 2 sets of slides. I'm just doing some at the end. Okay.
Can you check the proceedings now? I think I've uploaded them. David, can you find them? There's 2 lots for 7.3.
Okay, hang on. I hope the screen doesn't go away when I do this. So many places I could click. Let's click on the one that actually does something useful. Give me a minute. Okay, so if I hit reload here, give me a minute.
I can see Kuhn's slides now.
TikTok, everybody's retrieving their meeting materials right now. Yes, I now see 2 7.3, so we'll be able to get to all the slides from there. All right, let me go do my last piece of the fun here. Okay, so upshot here is agenda has been bashed. I can click on the right window. There it is. Agenda bashed. Second set of slides has been added meeting materials. Okay, so the first thing we've got to do is talk about what we're trying to get done. This is the chair's view of what needs to be done on the L4S drafts. So I'm going to read this, and with luck, between myself, other chairs, and some discussion, we'll have some clarity on what needs to happen. So there's two items that coming to this meeting need attention. The first is Transport Protocol independent requirements to use the L4S service, and the goal here is interoperability. Multiple transport protocols able to meet requirements, specs, and or implementations. Working group gets to decide what is sufficient, and that the doc that is crucial to this is the ECN L4S ID draft. The second thing needs to be done is safety of internet-wide L4S experiment. We really do not want to break the internet. In doing this, goal is that the experiment is unlikely to cause significant damage to the internet, and any damage results is expected to be tolerable. The draft for this is the L4S ops draft, and I'll reiterate something we said before. Working group last call on the L4S ops draft is not required to meet the safety goal. So that's not required. What is? The criteria for both goals is working group rough consensus that each goal has been reached, and the working group chairs will put on our Kevlar vests and figure out how to run initial consensus calls for the next IETF meeting week. Okay. Questions, comments, dead cats, rotten tomatoes? Dead silence. I was not expecting that. Those slides can't be that good. All right. I will call people. Bob, Greg, Kuhn. Is this reasonably clear and within reason?
Can I say go first?
Sure.
Yeah, it's relatively clear. Yeah, I just wanted the answers to the questions I put on the mailing list, which is more about the text in earlier emails, and just to get a confirmation that you didn't mean it rather than it just disappeared. You know, because this has become a bit of a no, I don't want that rock. Go and get another rock sort of type thing. And,
Okay.
and so
to continue that, this slide contains the descriptions of the two rocks. Get those two rocks, and we'll be in good shape. The crucial question I think you asked about whether I meant it was, do we need two interoperable implementations of the transport protocols onto LFRS? The answer is no. Working group gets to decide what suffices. The chairs will be satisfied that the working group believes that the requirements on the transport protocols are interoperable.
yeah, I mean,
So
yeah,
Bob,
okay.
we're talking about a specification with some requirements and/or implementations, but we're not talking about interop here. This isn't PS status. This is just existence status.
Right.
Does that help?
Basically, the goal is the working group needs to be convinced by rough consensus that the requirements and transport protocols are transport protocol independent.
I'm not worried about the interop thing. I'm worried. Most of the requirements are about performance, and that's not interop, and so it's, you know, or relative performance and stuff like that. So
You notice that word doesn't appear on this slide. That's deliberate.
Okay.
Performance and safety are not the same thing. However, complete absence of performance, i.e. you can't get traffic there from here, starts to look a whole lot like safety.
Yeah. I mean, we're
okay. We're on the same page here, because this is fundamentally the working group is going to have to make to borrow a badly used phrase, working group is going to have to make a I know it when I see it decision on safety.
Okay, let's move on, unless one of the other guys wants to say something.
Go ahead.
Yeah, can you hear me? Yeah, maybe the presentation that I will give also some insight on what implementations or planned implementations that we have. So hopefully that will help to decide whether it's the first point at least is sufficient.
Sounds good.
That's good. Thank you.
Jake?
Yeah, hi. One question about the last bullet point on number 2. Is this a like already determined criteria, or is that like a sort of goal in number 2, or the working group last call on L4S ops not required to meet safety goal? Like I wasn't.
Yeah, the primary reason for that point being here is that if the working group believes that the L4S ops draft lays out a reasonable safety case, but there's still quite a bit of work to be done on it, that's not a reason to hold up working group last call on the L4S drafts.
Okay. And this is a point for discussion?
This is certainly a point for discussion.
It's a point, Jake, we discussed last time round, where we talked about would the experiment actually help to inform the operational draft, to inform how operators did things. So did we want to close this before we started the publication process, or did we want to make sure it was reasonably good shape and then allow that draft to mature a little bit in the working group? And we didn't really decide on how much maturing was actually useful, needed. So this is the space in which the adoption call is being held.
Okay, sure. I mean, I guess, so this is about reaching consensus on these points, right? My only point
Yes.
is like, I tend to be of the opinion that I would like to see a normative language somewhere in the experiment, perhaps referencing the draft. I'm not sure whether the core L4S drafts go forward, but in the I guess we can get to that later after the adoption call, perhaps.
We
Yeah,
can
okay.
certainly get to that at working group last call on the L4S drafts, requesting a normative reference from the L4S drafts to the L4S ops drafts, so that they have to go forward as RFCs together is completely reasonable as a last call topic, if not
Okay,
before.
great. Yeah, thank you.
Jake, I'd
It's
like to
just that
ask a question. Jake, can I ask a question about the normative language? What are you saying? There might be normative language around the operations aspects that we somehow have to capture in the working group. Is that the comment?
Yeah, I guess. I mean, you know, I'm not sure exactly what form it would take, but sort of the to rephrase the opinion I put forth before, I think that the sort of current TCP Prague implementation seems incompatible with classic queues, etc. In the sort of safety sense, and therefore, like the sort of guidance around as a L4S sender, ensuring that you're operating on paths that do not contain classic queues is part of the safety story in such a way that I would prefer to see some kind of at least should to that effect, and the details of how the drafts precisely point to each other and whether it has to be an RFC first, I'm flexible on, but
Okay, and
but I just
that flexibility was the primary point of that bullet. Let's go and let's use that as an excuse to transition to the ops draft.
Great, thank you.
Let's see, am I supposed to put up Greg's slides, or Greg, do you want to put up your slides?
Could do it, that would be fantastic, but
All right, which means I got to go
I
get
have
them.
not tried.
Hang on a minute, I got to go get them.
Okay.
And I guess the position of the chairs on the normative language is, if we need normative language for the ops work, if that's what the working group concedes, then there will be a place to put that normative language. If that's what comes out, we'll find a place to do it if the working group needs it. So the fact that this is put up for adoption as informational doesn't constrain us as a working group from making RST 2119 language if we need it.
All right, let's go blink the screen. And with a little bit, few more clicks, we ought to have slides. Yeah, those.
Okay.
All right, Greg, I should be up. Tell me when you want me to advance slides.
Okay, thanks. All right, so this is the second, or actually the third iteration of the L4S ops draft. And just to reiterate what I said last time I presented, I'm the editor of this document. The contributors include those listed at the bottom, as well as probably others on the working group who have done reviews and made suggestions. Hopefully I didn't miss folks, but contributions of text to improve the draft are welcome, and I assume if this gets adopted by the working group, that we'll see more review and more contributions. So, all right, next slide. The scope of the draft, so as the name of it is operational guidance for deployment of L4S in the internet. That may sound like it's covering more ground than it actually is. The scope of the draft actually is specific to the issue of coexistence of L4S traffic and classic traffic in an RFC 3168 bottleneck. It has expanded since the last iteration to now discuss VPNs in FQ bottlenecks as well as single queue bottlenecks, although more elaboration on that could certainly be added. And the goal to provide guidance for operators of L4S hosts as they deploy L4S on the internet. Also guidance for operators of networks, in particular networks that are currently running RFC 3168 links. And then finally, recommendations for researchers. The goal of this document is not just to cover in-band detection and fallback. And that's an aspect that's been discussed within the working group of Paramount over the last year or more. It does include that, but it also includes some other aspects related to safe deployment of L4S.
Greg, you still there? We seem to have lost Greg's audio.
We've lost Greg's video as well, so he'll be back in a moment, I guess.
Okay.
Probably needs an L4S service to run effectively.
Gee, that was coming, wasn't it?
I would say that a standard FQAQM would work. That's what
All right, all right.
I think that was the problem.
Well, we'll wait a couple of minutes to see if Greg rejoins us, since he's in the middle of a pitch for adoption.
Miyako helpfully says in the chat that Greg lost connectivity and left the room.
Well, that's very helpful. But we
could
know
check
that Greg
in-
intends to return.
We could check in the meantime if people have read the document and
Yes, excellent. Why don't we start a poll? Can we work out how to do that on the tools?
I'll let you go fight that. I'm busy trying to
Yes.
make sure the slides work.
How many people? So I've just started a poll. If you go to the little bar chart at the top, this one's an easy one. How many people have read the, oh, you spelled people correctly, I didn't, have read the ops draft in one of its versions, just so we get a feel as a working group. If you'll click on that, please, if you've read one of these versions, so we know whether we're judging something that people have actually seen.
I see Jake's looking for the poll. In the Meet Echo icons, the upper right, it's the thing that looks like a bar chart. Not the most intuitive icon. I think that was designed for the chairs as opposed to the people who are supposed to participate.
Yeah. Okay, so
I see.
I'm currently see 14 people have raised hands, 25 have not. Press the do not raise hand button of 85 participants. So we have a number of people who've raised their hands saying that they've read this. And I'm going to end the session just now, and then we'll go back to Greg's presentation.
Yeah.
I'll report for the notes how many finally, we had 17 people said that they'd read this or a recent version of the ops draft. So 17 had read it. And we'll continue this after Greg's talk, if Greg's able to join us now.
Hopefully you can hear me.
Yes, welcome back.
Great. I'm not sure when you lost me. Did I get through the scope slide?
Probably about at somewhere after provide recommendations to researchers. If you quickly cover the last 2/3 of the slide, let's see if we can move to the rest of the slides quickly.
Okay. Well, the middle bullet is just a high-level scope. It's a little bit more detailed than the top bullet, but in a couple of slides, we'll go through a summary of the contents. So I won't spend time on that one. The last bullet is just to point out that general requirements for the experiment, etc., are intended to be included in the core L4S drafts, not in this one. But this draft does rely on requirements that exist in the L4S ID draft, including the ability for a host to disable the L4S functionality and for a host to monitor, provide statistics that can be used to monitor for presence of RFC 3168. All right, next slide. Status, this is the third version of the draft. Previous ones were discussed in previous IETFs. A new material this time addressed some comments around mentioning VPNs and FQCODL, that combination, as well as added discussion on fairness, per flow fairness, and then some general text improvements, which we can just go on to the next slide.
Greg, do you think the draft is to the point where review by operations folks would be helpful? Is it sufficiently complete and having operator folks look at and tell us whether it's reasonable and useful would be good, or do you need another spin on this?
I think it's at a state now where that would be useful.
Cool. We'll have to see if we can do that.
Okay. All right. So this is a summary of the contents of the draft. And I'm trying to think, in the interest of time, how much detail to go through here. Top piece, the draft does discuss prevalence of the issue and severity of the outcomes. That was a comment that was made recently on the mailing list that more material there could be helpful. So I don't disagree with that. So certainly would welcome contributions in that section. But the general statement of the draft is that L4S coexists well with classic traffic, aside from this issue with shared 3168 queues and the two scenarios where that comes into play. Then it's primarily an issue for long-running flows at high data rates with long RTTs. And the result of it is L4S flows outcompeting classic flows to one degree or another, depending on the scenario. And then has a summary of some historical issues around per flow fairness. The next bullet, there's a section that is dedicated to talking about detection of 3168 bottlenecks via experiments. And then that section is essentially intended to be useful not just for researchers doing experiments, but also for L4S host deployers to do experiments prior to turning on L4S or as part of their A/B testing as they enable a new congestion control. Right now, that section is essentially a pointer to the fallback report with a link on the lower right-hand side. But the intention is that we will summarize some of the most important methods that are in that report in the draft itself. But now it's just a pointer. One thing to note, there was some discussion on the list about this idea of having L4S nodes disable 3168 ECN, so disable CE marking of ECT0 traffic in order to facilitate detection of L4S versus classic 3168. Bob did a fairly in-depth analysis of that and thinking through it and put together some slides, which come to the conclusion that that may not be as useful as we maybe thought it might have been a few months back. So currently the draft does not recommend or assume that L4S nodes are doing that disabling of 3168 ECN. And then the last two bullets, guidance for operators of hosts and guidance for operators of networks that have bottlenecks, or the specific guidance and recommendations for those two constituents. In particular, on the host side, we've broken it out into general purpose servers, e.g. web servers, versus more specialized servers, for example, cloud gaming, cloud VR type applications, your non-TCP applications. And then also partition between edge servers, which serve a small population of networks or hosts, versus more general hosts that may be serving content across longer paths or a broader set of hosts. All right, next slide. There were some comments on the mailing list since the posting of Draft 02. As this summarizes those. And how are we doing on time? Do we have time to discuss these, or should I just mention them?
We should probably just simply, I think what you do is say that you've taken a look at these, some have been dealt with, some haven't been, and let's get on to some open discussion here.
Sounds good, yeah. So this is just a summary of those issues. We'll work on, be the mailing list, as well as, people have contributions with text that will improve the draft. Certainly those would be useful. All right.
Okay.
Last slide then is,
last slide says is an adoption call in progress. And I think it's productive to leave this slide up and open for discussion and comments. Jonathan, you're first. Go ahead.
Okay. Now, I could say a lot here, but I will restrict myself to talking about the long-running flows thing from the previous slide. And I'll just say that I disagree with that statement, and we should open a discussion about it on the list in the interests of meeting time.
Okay, thank you.
Okay.
Are there any more questions or clarifications from people on what Greg has presented?
All right, I think we probably got to run a sense of the room poll on draft adoption. You want to do the honors, Corey, and maybe people can find the and find the tool this time?
I have done it. So we're asking here, how many people think this ID, this internet draft, forms a basis for a work item in TSVWG, i.e. they support adoption and progression in the working group? Is this a basis for preparing a milestone for work on this? Please raise your hand if you support it. Please press the do not raise hand if you think this is not a basis for work.
And don't press either option if you prefer not to express an opinion either way.
Or if you haven't read it yet, so
we won't hold that again. We won't hold that against you.
Okay. So the numbers are settling down. Please go to the graph icon and press it if you wish to raise your hand to help us judge that this is ready for support. And please note that this is an informative poll. We do this usually in the working group to see how many people have read the document. We do monitor the list, and we also take this as input, but we do the actual call on the working group list where the adoption call is in progress. So that will conclude after the IETF meeting. So we won't be making an announcement at this meeting. Okay, we have a stable entry. I'm going to close it and report the numbers. So 25 people think this ID forms a basis for work in TSVWG to support adoption and progression in the working group. Thank you, Greg, for presenting that. Please make sure that you record any comments you might have on this in the working group email so that we know if there are any more concerns or comments on the adoption process itself. And we'll make a determination at the end of the period. David.
Right. And as noted in the minutes, we have one do not raise hand. I think that qualifies as sense of the room or sense of the virtual room is to adopt the draft.
Thank you for the summary. Yeah, I've noted that 1 against, 25 for. Okay, it's customary at this stage, if you wish, to allow you to come to the mic and say why you think that the position against is one that we should consider, but you don't need to.
It might be best to consider continued discussion on the list focused on the merits of the draft.
Excellent. Good.
Carsten, did you want to say something?
Carsten?
Nope. Hit wrong button. Happens all. Okay. All right. So next up, I need to go find which deck am I looking for to start with, Bob?
That should be mine. It's the
Right.
Prague requirement survey.
Bingo. All righty. And
okay.
So, and there it is. How about that?
Yep. Okay, thanks. So this presentation is about the Prague requirement survey that we did on the list. You might have seen it, hopefully. So it's an overview, quick going through it in matters of time. So maybe next slide. So these are the results that we got. So the goal of this survey was to get a view on how feasible, realizable the Prague requirements are at the moment, and whether they were supported by broad community, mainly, of course, people who would implement congestion controls. So we provided a template which listed all the normative requirements and the 3 performance requirements, which were also part of the initial TCP Prague requirements set, but are not really requirements. But anyway, sometimes considered as important performance requirements. And we asked 2 questions, whether you agree with this, whether you want to meet this requirement or not, and to what level, and then also another column to get more explanation, any issues, experiences, or even objections you have to the requirement. Maybe next slide. So we got multiple responses, of which 3 were publicly shared. So that was our own template, because we also gave as an example a filled-in template of the TCP Prague, plus then the Scream congestion control by Ingemar Eriksson. And then we also received the GeForce Now congestion control by NVIDIA. So they are listed, the detailed responses, they are collected on the link. You can have a look at them for detailed responses. We also got other responses shared privately, and at this stage we didn't get any confirmation whether we could make them public, so we kept it, we respected that. But we made a consolidated summary, which is also available on the same page, but directly in the document that you can find there on the link. Next slide. So to give a quickly a big overview, so these are requirements which everybody was agreeing with, let's say. They would be compliant and support it or plan to support that. It are obviously the obvious ones which you need to make it work, you could say. Maybe zooming in, so L4S sender must set ECT field to ECT1, ECN field to ECT1. There was a concern or a remark mentioned that operating system APIs and kernels did not support it yet. So it would be interesting to know what stops these operating system and kernels to put these functionalities into their mainstream. Is it really the release of RFCs of these documents or something else? So if there is some insight in that, that would be useful, because it would be useful to have these APIs today already, and that kind of rollout could begin to be less hurdled by experiments. And then another thing, maybe I zoom in, provide feedback to the extent of CE marking. Everybody wants that, obviously, but for the accurate ECN for the TCP protocol, for other protocols, there were not really, there were not any problems mentioned, but for TCP itself, the accurate ECN, there were still some remaining concerns. I think they need to be handled in the TCPM working group as soon as possible, let's say. Also, the must reduce RTT bias was broadly accepted, and also not part of the requirements also for the longer round trip times. They would implement or already implement this. And also another one, the rack requirement, let's say, should detect loss by in time-based units. All of them did already or are planning to do this. Also the non-normative performance suggestions were all accepted and seen feasible. And the results on the draft were only minor clarifications, let's say, that were asked. Next slide. The only strong objection that we got on the draft was related to the documentation only requirements, I call them here. So must specify in detail how the congestion control works, or how you define, quantify, and justify burst limit approach. So the objections were, are these documentation requirements really needed? How can we be enforced? May not be possible for proprietary protocols that don't want to share this. And it would also create a kind of precedence, I think, in IETF drafts to have a requirement, a mandatory requirement to describe the implementation in detail. So we remove these. I think that's fair enough. If you have objections on that.
Yeah. Could you put in some language encouraging people to publish this information for the use for the knowledge of the community? I have no problem with removing the must requirements. I think encouraging people to publish what they've done is always a good thing.
Mm-hmm. Yeah, I don't know whether it's still in there, but it's indeed we can do that, I guess. Then there are a set of requirements which needed experimental data, two high-level ones at least. The first one is to scale down to fractional congestion window. So not everybody's convinced that it really will be a problem on the internet, and they are not planning to implement it even. Multiple other ones already support it or have research code available. Or plan to implement it. So I think the should here is in the right place. And it is also not really a safety issue per se, because it's already handled by the AQM. When the signal starts to saturate, it should use drop anyway. So it would only be a kind of performance improvement to prevent latency if there is only alpha rest traffic or drop on coupled AQMs. So it's fair, I think, to look at further real experimental experience on that during the experiment. There was some updates on the draft based on discussions.
I have no idea whether should is appropriate. Please make sure the draft reflects the develop further during experiment, that this is one of the things the experiment is investigating.
It does already.
Good.
Yeah. And good.
Okay.
Gori has a question, or I think you're muted, Gori. Anyway, okay. Next requirement that needed experimental data, we all know, is the classic ECN detection. So there are a set of normative must and shoulds defined currently in the draft. There was some, let's say, confusion about what it exactly meant. Is the detection itself required? Is it well, obviously a robust detection scheme needs real deployment experience, and others say, yeah, but a combination with delay-based control would minimize potential issues. So it could also be a reason not to have this detection per se there, because it's already kind of circumvented by the latency aspect of it, which is currently not in TCP Prague, but several implementations have this. So first of all, yeah, it should be clear whether it's only the monitoring which is required, or also the detection is required. And I think the detection needs to be developed. Well, it's part of the discussion, and it's also what Greg already mentioned in the operational guidelines draft. Also clarifications on this automatically fall back. The next requirement says must be replaceable, while it could also be that the alpha S part is disabled, so it becomes in the same congestion control, so it becomes a normal classic response only congestion control. So there are multiple implementations possible, and also whether it is required on active flows or only on new flows, especially if it is being replaced. I think because of that hard statement, it could be. So anyway, also some clarifications and disambiguation is required there. And I think the requirements need to be aligned when the operational guidelines draft is adopted. So that needs probably some further clarifications. I see Jonathan and Bob ask a question, or?
Yeah, Jonathan, you're there first. Let's see if we can do this briefly here, as I'm sure we could have a multi-hour discussion on this if we wanted to.
Yes. Well, mostly I noticed that the references currently are to Bob Briscoe's paper on the subject. We have seen one of the algorithms from that paper implemented so far, and last year, and the results from that were not encouraging, shall we say. There is a second algorithm with a more active profile, which seems to have a better theoretical basis, but I would question how practical it is due to the volume of probe data needed to establish a statistical relationship. Mm-hmm. So, of course, we will need to discuss this in more detail.
Yeah.
Yes. Bob?
Bob?
Yeah, I just wanted to come in. I will also respond to Jonathan, but I originally came to the queue just to say that we haven't changed any of the text in the draft based on all this feedback from the survey until the adoption call is finished, because it, that makes a difference as to what the text is likely to be, So, but to respond to Jonathan's point, yes, that you've picked up the new idea we've put into that paper on using the spacing between marks to distinguish between classic and alpha S, and actually had another idea since then, which isn't in there, to use a pulse or a chirp to find whether the AQM is smoothing its response or whether it's an immediate response, which I think is possibly even more specific way of finding the two after it's finished its slow start and it's found some capacity and it's got some CE marking to do a pulse.
Okay, so I think let's see if we can get back to the slides. I think conclusion of slides, Kroon, sounds about right, which is more work, more more work needed in this area on the draft.
And potentially also the deployment experience, because well, the effectivity of all these schemes can only be evaluated during the experiment itself, I think. Then there was another compliant, or at least to the intent of how I think most people will interpret the requirement, but it could also be interpreted very strict, specifically coexist safely with TCP Reno congestion control. A lot of concerns are, what does it mean? I don't want to be as degraded as Reno for long RTTs. So there is already a discussion on the working group list to find the correct wordings for this requirement, because indeed we don't want that the congestion controls behave exactly like Reno, and especially not in the pathological cases. Then the last topic, maybe in general over all the requirements, is the balance between openness to innovation and to allow multiple congestion controls, and guidance and recommendations. We saw quite some requests for how should it work, how should this be done. So the goal of the draft at the moment, I think, is to keep it open for multiple congestion controls, even that certain people might or interpret certain requirements very strict, but that's definitely not our goal. So if you see like specific mechanisms being defined, that could be done otherwise. I think the result is important and not the mechanism shouldn't be defined, which doesn't mean that maybe certain numbers or interoperability requirements are needed. For practical examples, we have now also the TCP Prague congestion control draft in ICCRG released, the first version. So there it's described what TCP Prague is doing currently, but there are other open source implementations already which you can use for, let's say, mechanisms that could be interesting in solving many issues or mechanisms that can be used for better performance.
On the red text, I'd suggest a two-prong approach. One is, I see a list discussion on picking the precise words, and the other thing I would suggest is pick one or two well-known examples that do coexist safely TCP Reno, but don't have Reno's long RTT behavior, and include those, and that should get the point across.
Okay. Okay, thanks. As a conclusion, well, it's I think it was a very useful exercise to get a better view on the different positions. The strong objections were removed. Okay, there is still the suggestion we have to add. But it also made clear that live data is needed for those two, then at least, and for the rest, that there are quite already some implementations, and all the requirements are seen feasible and are planned to be implemented by most of the congestion controls. So other inputs are still welcome, preferably public, but if private, we can also take those for the next iteration if needed. Okay, that's it.
Okay. Comments, questions? I'll go get Bob's slides.
So my comment was rather quick. It was that there are other congestion controllers out there apart from Reno, and this isn't the place where we should in TSVWG be describing the complexities of sharing with different congestion controllers. So we need to use language which is wide enough, I think.
Yeah.
Not get bogged down in the details of Reno versus BBR versus Cubic versus.
Yeah. And for that matter, if the examples exist, the examples will both, if the examples are added, the examples would have two benefits. One is they would clearly show people that you don't have to have Reno's long RTT behavior requirement. And the other is they provide additional examples of congestion controls with which L1 traffic ought to coexist.
Vidi, I see you're next in line.
Question on similar lines. Like, I wanted to ask if it's during the experiment, if we have seen whether L4S congestion controller is fair, or does it coexist with cubic, like just doing the classic ECN.
Well, yes. So the current implementation is actually Reno. TCP Prague falls back to Reno behavior on drop. So it is definitely even with Reno, let's say, almost compatible. But well, these are things that most of the implementers for real deployments want to improve, obviously, and well, it's at that level that we probably need the correct wording.
Okay, Richard.
Just a clarification question. Did you ask for the response after a loss, or after the L4S has given you a proportional metric by which the congestion control should react, and then scale that depending on Urino or cubic?
For both. Loss is definitely, I think, one thing. I think it's same. I guess that's what Cohen was saying, that it's same for loss. It reacts in the same way. For feedback, what's the difference for the accurate feedback?
Maybe as a clarification, I didn't say that the TCP Prague requirements expect that it has the same response as Reno. We want to, in the TCP Prague requirements, or in the Prague requirements, better, we want to leave that open. Not describe the mechanism necessarily, I think, is the question here. When I say TCP Prague implementation in Linux, this is now the current implementation, but it's not like every congestion control should do this. So we have to be, also TCP Prague is not the congestion control for L4S or Prague requirements. Maybe we should never have called it TCP Prague because it's the confusion is like these requirements mean that the performance is not optimal in long round trip times or whatever claims. I think there are other implementations. We are kind of building a reference implementation for research. We are even not service providers and are not planned to develop a robust and very performant congestion control. So it's up to other people who have the right how do you call that? The right need for it to develop it, I think, and it shouldn't be like relying on us to do that job for them. I think that are the wrong expectations.
We've got a few minutes left. Let's go quick switch to Bob's slides. And Bob, if you can be really, really brief, we might be able to let Ingemar squeeze a word inside.
I was going to say, I'd in a way, I'd rather yield to Ingemar because I've had a look at his slides, but I'll just tell people what's in these slides and then they can go and look at them. If you can jump next slide. This summarizes it all really, that we're focusing on the congestion control implementation, particularly faster getting up to speed, which the abbreviation is GUTS, and so faster GUTS, and the other activities that have just been talked about are going on in parallel, obviously. Next. So there's a new draft documenting the Prague congestion control published yesterday. Some summaries there about it being protocol and OS agnostic, and this point about it not being the one true Prague that Kuhn just said. Next.
Skip this one, I think.
Yeah, just what's inside the draft. It's structured as,
here's where you are.
Yep.
And let me go find Ingemar's slides.
That's a summary of who's helped on all the drafts and what's changed and where we are. And that's it.
Alrighty. And Ingemar, go for it. Tell us something interesting.
Do you hear me? Yeah, do you hear me? Or do you hear me?
Yes.
Yeah, great. And how many? I will now roughly minus 1 minute left, and I will. How many minutes do you have before you cut the line?
Give yourself at least the 5 you're planning to take, and those who are interested will stick around.
Okay. This is about a master thesis that was done by David Brunel roughly 1 year ago, actually, and it was published, and you have the link there if you want to read all the stuff. And it's about online and cloud gaming in 5G, more or less, and it's based on L4S and an implementation in 5G RON of the L4S. We can skip this glossary and read it after the presentation if you like. But the outline is that we use a simulation, a system simulator, a proprietary one that models a typical 3GPP deployment or a 3GPP standard deployment with 21 cells, 7 base stations, and you have a rather narrow bandwidth and use a screen congestion control as a baseline for a typical congestion control algorithm that can run with or without L4S. And you have a variable load that is sort of increasing intensity of users, and also a number of background traffic loads that hammers the links to get a more credible scenario. And we run with various scheduling algorithms, which means that you're scheduling one user at a time in a 5G system. And first we have a round robin scheduling that is typically used for normal mobile broadband traffic, and then you have something called quality of service. They give a enhanced priority for the gaming users. And you can skip the next slide. And we use here a queue-based. That means okay. This is how we can realize it in a 3GPP network. Is that we use the quality of service framework where you sort of set up an extra barrier actually for the L4S flows. And that means that you can keep the latency low of that flow, and of course it assumes that it's only L4S traffic. Then you can L4S mark that. And for that, we can use the traffic filters that are available and remap the flows that have this L4S or that are L4S capable to that flow. And you can possibly combine it with IP5 tuple if you like also. And next slide. Okay, perhaps you need to go back 2 slides here. Okay. Then we have what we are using is this queue-based L4S marker, which means that you measure the queue build-up on the RLC layer, but you mark on the PTCP layer. And the reason why you do that is that the IP packets on the RLC layer, they are hidden by encryption. So you need to actually feed up the marking to the PTCP layer where the IP header is visible. And essentially that is you can call it tail marking or feedback and forward or whatever you call it in the IETF nomenclature. And you have some typical thresholds, and you go to a probability marking. And the threshold in the simulation studies that you have is a high and a low threshold that are 5 and 10 milliseconds. That can depend on what kind of numerology that you are using. And is it a time division duplex or is it frequency division duplex? So we can you probably need to tune those depending on what kind of raw next that you are running. Can skip 2 slides. I can believe you can jump. And this sort of shows a time trace comparison when you are using not L4S in a congested network, in a congested situation where the bitrate needs to go down to like 30 megabit per second or even lower to avoid queue buildup. First, you have a not L4S, and you use a round robin scheduler, and you see that you have the network queue delay spikes up to like almost 150 milliseconds, and that can sort of seriously harm the performance for online gaming or cloud gaming. And then you have you enable L4S. You keep the same scheduler that is used normal mobile broadband. You can see that you reduce the bitrate a bit, but on the other hand, you get a much lower queue delay. And then you have, if you have used queue quality of service, you can actually increase the bitrate a bit because you push back normal mobile broadband users, and you still keep the same low delay. That's what the QoS gives. Next slide. Here we look at the video frame delay, and here I must say that this video frame delay also accommodates that you have some capturing and coding delay also in the soup. That's why it's, the minimum is 40 milliseconds here. What is important here is to see that with L4S marking, you manage to keep the video frame delay low up to a relatively high load in the system, as compared to those when you're not using L4S. And you can probably skip the next one here. And also one important, okay, perhaps one back. Yeah, okay. You are really in a hurry here, but okay. And what the important here is what the L4S manages to keep the network queue delay low, and that is shown here. That you manage to keep the network queue build up very low, and that is the main purpose of the L4S here. And also, if you use additional quality of service, of course, you improve the performance, because that means essentially that you can push back other users in order to keep your queue delay budget. Next slide. That shows the transmitted rate, and here that is something that is up to discussion here, is maybe online or offline, and is that you actually trade off a bit of a throughput in order to get a lower delay. And part of the reason is that video encoders typically have a very varying frame sizes, which is shown up in the upper right graph here. And another one is that you have in the cellular access, you have fast fading. That means that the throughput dips on a millisecond basis. So you need to have some extra headroom in order to get the queue delay build up. So that means that you actually push down the bitrate a bit. But that is a trade-off that you need to do, and there are also no shortcuts here. One shortcut is, of course, if you have a very strict priority scheduling, you can push out all other users, then you can get your throughput, but get other problems instead. And I believe it probably stops there, unless there are any questions, and we're running out of time. And
Ingeborg, where do we get the full details of this? We've uploaded the slides in the slide deck. Is the thesis available?
Can you repeat it? I didn't hear quite.
Where do we get more details of what you've just presented? Where can we find it?
You will find it in the multi-thesis presentation if you on the link on the first page here.
Yeah, thank you. That was interesting. Thank you so much.
Yeah, in fact,
It's 116 pages.
Yeah, let me go carefully copy that link into the minutes, since I can do the cut and paste.
Okay, great.
And thanks everyone who presented. Thanks for keeping to time. We had quite a lot of stuff going on in TSVWG this time round, and it was good to have lots of participants. We will have a number of adoption and last calls coming up on the list. Please look out for them. And we do look forward to seeing you in other IETF meetings and the next TSVWG meeting.
And we've clearly demonstrated that we need to go back to asking for at least 4 hours in the future. 3 hours is not enough this time. Sorry about that.
Wes, have you anything finally to say?
No,
well, sorry.
You could hear me.
Yeah, go ahead, Wes. Excellent. Okay, if you were going to prepare presentations for the next meetings. Please do stick by the deadlines or send them in advance. Last minute presentations are really challenging in agenda planning. But apart from that, we just wish you the best and keep talking on the list.
Thank you very much, everybody.